Hi everyone. In TPS activity, we have discussed about the different data related addressing modes and how the effective, what will be the format of effective address in each of the addressing mode. So let us continue the same thing till physical address calculation, and before that we will have the overview of the different data related addressing modes. So there are 8 data-related addressing modes: immediate, implicit, direct, register, register indirect, relative register, based index, relative based index addressing mode. So let us start with the first one. In immediate addressing mode, here the immediate data will be present in the instruction. So it does not involve any physical address or the effective address calculation. Even in implicit addressing mode, the operands will be implied in the instruction itself. So here again no physical address or the effective address calculation will be involved. Moving on to the next addressing mode, which is a direct addressing mode. So here the effective address or the 16-bit displacement is a part of the instruction. So the either a 16-bit address specified in the instruction itself is an effective address. So by making use of that, we can calculate the physical address. The general equation to calculate the physical address is physical address equals to effective address plus 10 into segment address. So which we can highlight here. It is nothing but physical address is equal to 10 into ds plus ea. Okay. Next, let us take an example in direct addressing mode. Move CL, 9823H. Here 9823H is an 16-bit displacement. So this indicates the effective address. So this segment address into 10 plus this displacement will gives us the physical address. Now moving to the next addressing mode, which is a register addressing mode. In register addressing mode, the data will be provided in the register itself. So here we don't have to calculate the physical address or the effective address. Next, register indirect mode. In this case, the address of the data will be specified in the register. We can use either BX and or BP as an register, and also SI or DI as a base registers. So an example for that is move di content of di comma bx, that is the content of di indicates the offset address here or the effective address. So effective address plus ds into 10 will gives us the physical address. In register indirect addressing mode, the content of register indicates the address that into, so plus 10 into ds will gives us the physical address. Now base index addressing mode, as the name indicates here, we use both the base register and the index register for the effective address formulation. We can choose either SI or DI as a base register and index register, and BX or BP as an index register. So here let us take an example of move AX, BX SI. Here BX is a base register and SI is an index register. Sum of these two will gives us an effective address, and effective address plus 10 into DS will gives us the physical address. Another addressing mode, that is register relative. So in this case, the content of register plus an 8-bit or 16-bit displacement will gives us the effective address, and this effective address plus segment into 10 will gives us the physical address. So we can choose either BX or BP or SI or DI as one of the base registers. An example, move AX, 50H. So 50 indicates the displacement and BX indicates the base register. Sum of these two will gives us the effective, and adding it to the content of segment into 10 will gives us the physical. Now finally, relative based index. Here we have to consider base register, index register along with the displacement. Relative indicates the displacement here could be 8-bit or a 16-bit. So addition of all these three will gives us the effective address, that plus 10 into DS will gives us the physical address. Okay. So next let us take one example based on this. With this given data, let us calculate the physical address in all the addressing modes. Here the base register they have given as a BX and BP. So in this case we have to choose any one as a base register, and here index register is mentioned as a DI. So there is no confusion about selecting the index register, and displacement is about 16-bit displacement, and data segment is provided as a segment register. So now let us start with the register addressing mode. As I told, in register addressing mode, data will be provided in the register itself, so no effective address or no physical address will be involved in this case. In immediate addressing mode, even here, immediate data is a part of the instruction, so we don't have to go for calculating the physical address or the effective address. In register indirect addressing mode, so we have, let us choose BX as a base register. You can either choose BP as a base register unless they specify use this particular register as a base register. So I have used BX as a base register. So content of BX is my effective address. So this effective address plus DS into 10 will gives me the physical address. Now moving to the next other type, register relative. Throughout this example, I have chosen VX as a base register here. Okay. Now, register relative. So we have to choose base register plus displacement for the effective address and add this to the segment multiplying with the 10 will gives me the physical address. In this case, we get the result as 22CAFH. The next one is base index. In base index, the base register and index register content will gives me the effective address. So I have chosen BX plus DI as an index. In case if SI is given, if they have not specified anything, you can choose any either SI or DI as an index register, but we need to mention it. Okay. Okay. So so physical address will be the effective address plus DS into 10. Relative based index, we have to include the displacement along with the content of BX and then SI. So this is about how we calculate the physical address. Let me just extend this to a further small topic, so which is about how we can identify the segment address with the given physical address and then offset address information. So we know that physical address can be calculated as segment into 10 plus offset. So with this, we can find out the segment address as physical address minus offset divided by 10. That's it. Thank you.